10:07 a.m. September 1st, 1939. A Bf-109 from IJG-1 slices across the Polish frontier at 350 mph. Its DB-601 engine screams at full power. Polish PZL fighters scatter. Within only 4 minutes, 3 are burning on the ground. The fighter that just opened Europe's bloodiest war was nearly canceled 3 years earlier. Its designer faced deliberate sabotage, personal vendettas, career annihilation. His boss wanted him destroyed. The prototype bounced violently on every landing. Test pilots called it a death trap. Political enemies used a fatal crash from 1930 to bury him. Yet this condemned machine became the most produced fighter in history, 34,000 built. What turned a prototype marked for death into the weapon that rewrote the rules of air combat. Germany's rearmament accelerates through the mid-1930s. The Versailles Treaty lies in shreds. Secret airfields multiply across Bavaria and Prussia. The Reichsluftfahrtministerium, the RLM, launches a competition that will define the coming war, a new single-seat fighter. Speed, firepower, mass production. The demands are absolute. 2 companies enter the deadly race. Heinkel and Messerschmitt. They represent opposite philosophies. Heinkel builds elegant machines that pilots love. Messerschmitt builds efficient ones that bureaucrats fear. But one man poisons every decision before it's made. Erhard Milch, State Secretary of Aviation, the second most powerful man in German aviation, and he despises Willy Messerschmitt with personal fury. The hatred runs back to 1930. Messerschmitt's M-20 transport crashed on a demonstration flight. 1 passenger died, Milch's close associate. Milch watched the wreckage burn. He has never forgiven. He will never forget. Now he controls contracts, budgets, decisions. He blocks Messerschmitt at every turn, whispers to Hermann Göring that Messerschmitt is incompetent, dangerous, unreliable. Every proposal from Bayerische Flugzeugwerke gets scrutinized twice as hard. Every budget request sits on desks for months. Milch wields the M-20 tragedy like a knife, reminding officials again and again that Messerschmitt's designs kill people. Meanwhile, test pilots at Rechlin fall in love with the He-112. It's beautiful, graceful, stable. The cockpit feels spacious. Controls respond like silk. The wide landing gear plants firmly on every touchdown. Ernst Heinkel's team has built a pilot's dream machine. Then they climb into Messerschmitt's Bf-109. The cockpit feels like a coffin, angular, cramped, claustrophobic. The narrow undercarriage makes every landing a gamble with death. Visibility is abysmal. Canopy frames block critical sightlines during approach. Pilots walk away shaking their heads. Some refuse to fly it again. The verdict spreads through Rechlin like a disease. The Bf-109 will kill students. Yet the Luftwaffe's desperate need overrides comfort. Germany knows war is coming. Soon. Factories must vomit fighters into the sky, hundreds per month, then thousands. The RLM doesn't want elegance. Elegance takes time. They want simplicity. Brutal modularity. Assembly line speed. A fighter that exhausted mechanics can service in muddy fields without specialized tools. A design that dispersed factories across Germany can build simultaneously without confusion or delay. The aircraft must be practical, not pleasant. Producible, not pretty. Victory will belong to whoever gets more fighters airborne first. The competition intensifies into a bureaucratic war. Prototypes fly in direct comparison. Performance data accumulates in thick folders. Milch pushes relentlessly for the He-112. He argues in closed meetings. He manipulates reports. He threatens careers. Messerschmitt fights for survival with data and desperation. Engineers in Augsburg work through nights refining blueprints under dim lights, testing components until they crack, searching desperately for any advantage that might save the program. The Luftwaffe stands paralyzed at a crossroads. Choose beauty or choose momentum. Choose comfort or choose speed. Choose the fighter pilots want or the fighter Germany can actually build 30,000 of. The decision will determine who controls the sky when the war everyone fears finally erupts. One engineer's career hung by a thread while Germany's future air superiority rested on a single bureaucratic decision driven by personal vengeance. Willy Messerschmitt is Bavarian to his bones, proud, stubborn, uncompromising to the point of self-destruction. Born in 1898, he built his first glider at 15 with scrap wood and stolen wire. He learned engineering through brutal failure wings that snapped mid-flight structures that collapsed under stress designs that nosedived into dirt. Each crash taught him one lesson: simplicity survives. By the 1920s, he runs Bayerische Flugzeugwerke in Augsburg. His reputation grows among pilots who value raw performance over comfort. But his enemies multiply faster than his contracts. Milch's vendetta isn't professional, it's personal and all-consuming. The M20 crash haunts every interaction like a ghost. Messerschmitt's proposals are questioned before the ink dries. His budgets are dissected line by line, searching for any excuse to reject them. His contracts disappear into bureaucratic black holes for months. Critics in Berlin call him reckless, a cowboy, arrogant. They say his designs sacrifice pilot safety for speed records. They point to accidents as proof. They whisper that he's too independent, too Bavarian, too contemptuous of Berlin's authority to be trusted with national security. Some suggest he's politically unreliable. The rumors spread through the Air Ministry like poison. But Messerschmitt's engineering team believes in a radically different philosophy. Strip everything to the bone, ruthless simplicity. A small airframe means less drag fighting against you at high speed. Tightly integrated systems mean fewer components to fail in combat. Maximum speed means survival when enemy fighters swarm. They tear away everything unnecessary. The fuselage is narrow, barely wide enough for the pilot's shoulders and fuel tanks. The wings are thin as knife blades, minimizing parasitic resistance. The tail is compact, reducing dead weight at the extremities. Every component faces interrogation. Every gram must justify its existence. Nothing is added for aesthetics or pilot comfort. Beauty is a luxury. War demands efficiency. They know the He 1-on-12 is prettier, much prettier, more pleasant to fly, easier to land without dying. Pilots praise its forgiving stability. Evaluators write glowing reports about its gentle handling. But Messerschmitt's team doesn't design for praise. They design for the war that's coming, for production lines that must stretch across an entire nation, for mechanics who'll work with frozen fingers in forward airfields, for pilots who need speed more than a comfortable seat, for a conflict that will devour 30,000 fighters, not 300. They see what the bureaucrats refuse to acknowledge: Germany will need crushing quantity as much as quality. The side that gets more fighters into combat first will own the sky. Messerschmitt himself is ice under pressure. He doesn't charm officials at cocktail parties. He doesn't soften hard truths with diplomatic language. He presents raw data, performance curves that don't lie, projected production rates calculated to the day, weight-to-power ratios that expose competitors' weaknesses. He tells the RLM exactly what they don't want to hear: that elegance is a luxury Germany cannot afford in the coming war. That beauty becomes irrelevant when enemies outnumber you 3-1. That victory will go to the fighter that can be built fastest and flown hardest when everything is burning. His blunt tone alienates bureaucrats who expect deference, but his logic is a steel trap. Unassailable. His team works in near isolation at Augsburg. Funding arrives sporadically or not at all. Political support is non-existent. Milch ensures that. The opposition is constant, vocal, and powerful. They refine the design in desperate secrecy, testing each component past failure points, pushing materials to their limits. The landing gear stays narrow because widening it means redesigning the entire wing structure and losing 6 months. The cockpit stays cramped because expanding it increases frontal area and kills their speed advantage. Every compromise is calculated. Every apparent flaw is deliberate. Every decision balances performance against the brutal reality of mass production. They're not building a showpiece for air displays. They're building a weapon for industrial-scale war. And Messerschmitt waits with quiet fury. Waits for the inevitable moment when combat performance will silence political enemies. When test data will prove him right. When the war everyone fears will vindicate every unpopular decision he's made. He didn't build what pilots wanted to fly. He built what Germany would desperately need when the sky became a slaughterhouse and only speed kept you alive. The early prototypes fail spectacularly. May 1935, the Bf-109V1 lifts off for its first flight. The takeoff is violent. The narrow undercarriage bounces hard against concrete. The aircraft veers sharply left. The pilot fights the controls. Ground observers hold their breath. The landing is worse a nightmare in slow motion. One wing dips dangerously low. The tail skips twice. Wheels screech and smoke. The aircraft shudders to a stop at the runway's edge. Test pilots climb out pale and shaking. "It's a killer," one mutters. "This thing will murder students." Word spreads through Rechlin like wildfire. Messerschmitt's fighter wants to kill its own pilots. Rechlin evaluators sharpen their knives. The He-112 scores higher in every category pilots care about. Comfort, stability, forgiveness, control harmony, ground handling, visibility. One senior evaluator writes a devastating sentence. The Bf-109 demands constant attention during every phase of flight. It will kill inexperienced pilots without mercy. We strongly recommend the He-112 for all training and operational roles. The report circulates through Berlin. Milch seizes it like a weapon. He marches into Göring's office demanding immediate cancellation. Messerschmitt's death trap will slaughter Germany's young pilots before the war even starts. Then the range crisis detonates. The Bf-109's tiny fuselage leaves almost no room for internal tanks. 90 minutes of flight time. Maybe. Takeoff burns fuel. Climb burns more. Combat drains tanks in minutes. Drop tanks are proposed, but they kill the fighter's only advantage, speed. They increase drag dramatically. The RLM runs calculations repeatedly. A fighter with such pathetic endurance can't escort bombers deep into enemy territory, can't intercept raiders far from home, can't fight sustained engagements. The Bf-109 seems condemned to defensive missions near its own airfields, useless for the offensive war Germany is planning. Milch smells blood. He intensifies his campaign with ruthless focus. He uses the M20 tragedy like a hammer repeatedly, publicly, without mercy. He reminds officials in every meeting that Messerschmitt's designs have already killed people. He questions whether Bayerische Flugzeugwerke has the industrial capacity for contracts demanding thousands of fighters. He circulates rumors that Messerschmitt is politically unreliable, too independent, too Bavarian to be trusted with the Reich's most critical weapon. He suggests Heinkel is the proven choice, the safe choice. The pressure becomes suffocating. Inside Messerschmitt's Augsburg workshops, morale collapses. Engineers hear the whispers from Berlin. They watch contracts flowing to Heinkel while their funding evaporates. Some openly suggest abandoning the project before it destroys the company. Others propose desperate redesigns, widen the fuselage, enlarge the wings, soften the controls, redesign the landing gear from scratch. Arguments in design meetings become heated. Voices rise. Fists pound tables. Messerschmitt refuses every compromise with cold fury. "We don't change the fundamental concept, we refine the execution." But doubt spreads like cancer. Even his most loyal engineers lie awake wondering if the fight is already lost, if Milch's vendetta will bury them all. For one terrible moment, cancellation seems inevitable. The He-112 is prettier, safer, universally more popular. Milch controls the levers of power. The bureaucracy overwhelmingly favors Heinkel. Messerschmitt's fighter is faster, but speed alone cannot overcome institutional opposition backed by personal hatred. The Bf-109 teeters on extinction's edge, one unfavorable meeting away from erasure. one signature away from becoming a forgotten footnote about a stubborn Bavarian who bet everything on the wrong philosophy and lost. The fastest prototype in Germany was about to be executed by the slowest, most lethal force in any government bureaucratic spite wielded as a personal weapon of revenge. Messerschmitt makes a desperate gamble. He bypasses official channels entirely. Milch controls those like a fortress. He goes straight to Göring through back rooms at air shows and receptions. He reframes everything, stops presenting the Bf-109 as a competitor, instead presents it as a symbol, a fighter embodying German engineering superiority. Aggressive, uncompromising. Built for dominations, not comfort. Göring listens with growing interest. Göring loves symbols more than specifications. He loves being associated with speed records and machines that intimidate enemies before the first shot fires. But the real breakthrough comes from Ernst Udet, the legendary First World War ace with 62 kills, the man who understands combat from the cockpit, not conference rooms. Udet demands to test both fighters personally at Rechlin. He straps into the He-112 first, takes off smoothly. The flight is pleasant, stable, comfortable. Landing is effortless. He climbs out, nodding appreciatively. Then he walks to the Bf-109, squeezes into the cramped cockpit. The engine fires with a violent roar. He advances the throttle. The acceleration hits like a physical blow. The fighter claws skyward at an impossible angle. He pushes into a dive speed, builds instantly faster than anything he's ever flown. Pulls into a vertical climb. The horizon disappears. His vision grays from G-forces. He rolls inverted and dives again. Control response is instantaneous, brutal, unforgiving. This isn't a trainer. This is a pure killing instrument. He lands with his heart pounding and writes one devastating line, "This one will kill more enemies." But Udet's endorsement alone won't save the program. The RLM still obsesses over production scalability. Can Messerschmitt's small company actually build thousands of fighters? Udet visits Augsburg unannounced, examines blueprints, watches workers assembling components. Then he sees what Berlin bureaucrats completely missed: the brilliance hiding in plain sight. The Bf-109 is designed in independent sections, wings built in one factory, fuselage in another, tail sections elsewhere, engine mounts standardized, components interchangeable across variants. The entire aircraft can be produced by scattered factories, then shipped to assembly points for final integration in days. No specialized jigs, no custom tooling, no master craftsman needed, just standardized fixtures and simple bolted connections. Speed of production isn't an afterthought, it's embedded in every design decision. This fighter was designed from the beginning for mass production at industrial scale. Under crushing pressure to arm the Luftwaffe, Udet chooses the Bf-109. Not because it's safer, it isn't. Not because pilots prefer it, they don't. But because Germany can manufacture 10 Bf-109s in the time it takes to build 7 He-112s. War is mathematics, cold arithmetic. The side that gets more fighters airborne first controls the sky. The RLM signs the contract in late 1936. Messerschmitt survives by the thinnest margin. His company is saved, his career rescued from oblivion. Milch's vendetta fails. Now comes the critical technical breakthrough. The narrow landing gear stays redesigning would delay production 6 months. But engineers install automatically deploying leading-edge slats licensed from Handley Page in Britain. The slats extend at low speeds, dramatically improving lift and control during takeoff and landing. The handling problem that nearly killed the program becomes manageable. Not solved, managed. Pilots learn to compensate. The Bf-109 is no longer impossible to land, just deadly unforgiving. And unforgiving machines forge better combat pilots. The engine evolves rapidly. The underpowered Jumo Tulen-10 is replaced by the revolutionary Daimler-Benz DB601. Direct fuel injection eliminates carburetor icing during negative G maneuvers, a killer in combat. Power surges from 610 to 175 horsepower. Speed jumps dramatically. The Bf-109 reaches 350 meters in level flight faster than any Allied fighter operational, faster than the Hurricane by 40 meters, faster than early Spitfires, faster than anything in the French Armée de l'Air. Against every dire prediction, the fighter dismissed as a dangerous failure becomes unstoppable. A new era detonates. The Bf-109 enters full-scale production. Factories in Augsburg, Regensburg, and Wiener Neustadt assemble airframes around the clock. By late 1937, the first operational Luftwaffe squadrons received their aircraft. Pilots complain bitterly about the cramped cockpit. They curse the treacherous landing gear. They demand better visibility. But every complaint dies the first time they engage an enemy fighter in actual combat. Speed erases all doubt, and the Bf-109 is faster than anything else in European skies. One bureaucrat's desperate gamble on production efficiency over pilot comfort created the Luftwaffe's backbone and reshaped air combat across 3 continents for the next decade. Spain becomes the killing ground where theory meets reality. July 1936. Civil war explodes. Republican forces clash with nationalist rebels. Germany sends covert support advisors, equipment pilots operating in shadows. The Condor Legion forms by November. Among its units is Jagdgruppe 88J88. Their mission is brutally simple test German aircraft in actual combat, validate tactics with blood, identify weaknesses before the real war begins. The Bf-109 arrives in Spain in early 1937. Pilots strap in for the first time over hostile territory. The baptism by fire starts now. The first engagements deliver shock. Soviet-built I-15 biplanes and I-16 Radas are nimble and well-armed, but they're slow. The Bf-109 climbs above them effortlessly, dives through formations like a hawk, fires concentrated bursts, climbs back before Republicans react. I-16 pilots try desperately to turn fight, but the Bf-109 refuses. It dictates terms. German pilots develop boom and zoom, altitude advantage, high-speed dive, single firing pass, immediate vertical climb. The I-16 pilots can't catch the diving 109, can't escape the climbing 109. Kill ratios tilt heavily German within weeks, but Spain exposes the fatal flaw. Fuel endurance is catastrophic. Pilots flying bomber escort watch gauges with growing panic. He-111 and Do-17 bombers penetrate deep into Republican territory. Fighters must turn back early or die. Several Bf-109s are lost not to enemy guns, but to empty tanks pilots forced to belly land in hostile country or bail out over enemy lines. Engineers explore desperate solutions. Drop tanks, larger cells, nothing works. The compact design leaves no room without starting over. Then come experiments born from desperation. One proposal is insane, towing Bf-109s behind Bf-110 twin-engine fighters to extend range. It's actually tested over Spanish skies. A Bf-109 connects to a Bf-110 via reinforced cable. The 110 provides thrust. The 109 glides behind, conserving fuel. It works for 3 flights. Then combat turbulence snaps the cable at 8,000 feet. The 109 nearly spins into the ground. The pilot barely recovers. The test is abandoned. Too dangerous when bullets fly. Another radical concept emerges: glider fighters. Stripped Bf-109 airframes launched by tow, descending silently without engine noise. The idea is shelved, but the seed is planted. Years later, the Blohm & Voss BV-40 follows this exact philosophy, a tiny rocket-armed glider designed to ram Allied bombers. The BV-40 never sees combat, but Spain proves the concept. Silence as weapon, surprise as force multiplier. Every dogfight becomes a brutal classroom. German pilots learn altitude equals life. That energy management trumps sustained turning. That one well-aimed burst from the 20mm cannon through the spinner kills more effectively than prolonged machine gun fire. The Bf-1009's concentrated armament 2 7.99 mmGs, one centerline 20 mm, becomes the template. Centerline weapons eliminate convergence problems. High velocity ensures accuracy. Republican pilots adapt as casualties mount. They avoid vertical engagements. They hug the ground, forcing low-altitude fights where speed advantage diminishes. They exploit the 109's poor rearward visibility. They target German pilots during landing when narrow gear and high speed make the fighter most vulnerable. The war becomes a laboratory soaked in blood. Each side learns. Each side pays in lives. But the Germans learn faster and document everything. By 1939, J-88 pilots returned to Germany carrying something more valuable than medals: combat experience burned into muscle memory. Refined tactical doctrine written in survival. The fighter still punishes mistakes, still kills its own pilots during a landing, but it wins consistently, decisively, and in war winning erases every other complaint. Spain taught the Luftwaffe one unforgiving lesson: speed wasn't just an advantage, it was survival itself, and survival was the only metric that mattered. War explodes across Europe like a shockwave. Poland falls in 4 weeks, France in 6. The Bf-109 evolves with terrifying speed. The E-model Emil dominates the Battle of Britain in 1940. Its DB601 engine screams with 175 horsepower. Top speed exceeds 350 miles per hour. Range improves slightly with drop tanks, but the channel becomes a killing zone. RAF pilots exploit this mercilessly. They force Bf-109s into extended dogfights over England. German fighters burn fuel rapidly, turn for home with gauges reading empty, run out over gray waters. Pilots bail out. Many drown before rescue arrives. The 109's greatest weakness becomes a death sentence over Britain. The F model arrives in 1941. Friedrich, a revelation, streamlined, refined, faster than anything before. Wings completely redesigned with cleaner lines. The nose lengthens for the improved DB601E, generating 1,350 horsepower. Pilots call it the best handling Bf-109 ever built. It climbs faster, turns tighter, fires more accurately. On the Eastern Front, it slaughters Soviet fighters. VVS pilots flying outdated I-16s and underpowered LAGG-3s die in unequal combat. German aces accumulate kills in triple digits. Erich Hartmann alone claims 352 victories, most in the Bf-109. The fighter becomes synonymous with Luftwaffe supremacy across 2,000 miles of front. But the expanding war demands more than dogfighting. The Bf-109 adapts to roles never imagined. Reconnaissance variants carry cameras in modified fuselages. Night fighters mount radar pods beneath wings. Tropical versions deploy to North Africa with sand filters and survival kits. Even more exotic parachutist capsules are tested for clandestine insertions behind enemy lines. The concept never reaches production, but tests prove the airframe's versatility. Engineers push in every direction: speed, range, firepower. Each variant reveals hidden potential. The G model Gustav becomes the workhorse from 1942. Heavier, more powerful, armed with twin 13mm machine guns and underwing 20mm cannon gondolas. It enters service mid-1942 and remains in production until Germany collapses. Over 24,000 Gustavs are built, more than any variant. They fight everywhere simultaneously. Over Russian steppes, over Italian mountains, over burning German cities. As Allied bombers darken skies daily, the Bf-109 transforms into a bomber-destroyer. Pilots attack from above, diving vertically through formations, firing into engines and fuel tanks, pulling away before defensive gunners track them. The tactics from Spain boom and zoom scale perfectly to industrial warfare. The landing gear design influences future projects unexpectedly. Engineers studying the revolutionary Me-262 jet examine the Bf-109's narrow-track philosophy. They adapt concepts, tricycle nose-wheel, compact retraction, while retaining lessons from a decade of operations. The Me-262's gear reflects Messerschmitt's obsession with simplicity. The philosophy persists into the jet age. Facing the Bf-109F RAF Spitfire squadrons rewrite their tactics completely. The Spitfire's turn radius remains superior, but the 109F climbs faster, dives faster, accelerates away before Spitfires close range. British commanders learn through bitter loss to avoid head-on passes against the centerline cannon. They attack during vulnerable moments, landing takeoff low-altitude turns where speed can't compensate. They learn the Bf-109 isn't invincible, just faster, just more vertically focused. The sky becomes a three-dimensional chessboard. The Bf-109 dictates vertical rhythm. Allied fighters respond horizontally. Germans adapt vertically again. The cycle accelerates. Combat footage captures the pattern, Bf-109s climbing steeply rolling inverted diving at terminal velocity. Spitfires and P-51s pursuing unable to match separation speed, re-engaging at altitude where it begins again. Altitude converted to speed, speed to position, position to survival. The principles Messerschmitt embedded in 1935's small, fast, uncompromising reshape how every Air Force trains pilots for the next generation. One fighter's radical efficiency didn't just dominate the war, it redefined what every other Air Force had to become to survive against it. Ambitious offshoots appear in design bureaus, then vanish like ghosts. The Me-155 emerges in 1942, a high-altitude interceptor designed exclusively for carrier operations aboard the Graf Zeppelin, Germany's only aircraft carrier. The 155's wings are dramatically elongated for low-speed approaches. The cockpit is pressurized and reinforced. The landing gear is massively strengthened for arrested landings on pitching decks. Engineers complete wind tunnel testing. Prototypes are partially assembled, but the Graf Zeppelin never sails. Construction halts in 1943 as resources shift to U-boats. The carrier is towed to Stettin, abandoned, then scuttled in 1945. The Me-155 dies with the ship. A fighter meticulously designed for a carrier that never fought. Hours of engineering erased by strategic failure. The Me-109Z Zwilling twin appears next. Two complete Bf-109 fuselages joined by a central wing section. Twin engines, twin cockpits, dramatically extended range, massively increased firepower. The concept promises salvation, long-range fighter bomber, and heavy escort in one airframe. A prototype is assembled at Rechlin in 1943. Test flights show promising data. Range doubles. Firepower increases. Stability improves at high speeds. Then disaster strikes. Early 1944. An Allied daylight raid hits Rechlin directly. The irreplaceable Me-109Z prototype burns completely before testing finishes. No second prototype is built. Documentation burns in the fires. The Zwilling fades into footnotes. Yet the twin fuselage concept survives elsewhere. The American P-82 twin Mustang follows precisely the same philosophy, two fuselages, one connecting wing, extended range for Pacific distances. North American Aviation builds it for ultra-long-range escort over ocean expanses. The P-82 enters service in 1946. It sees extensive combat in Korea starting in 1950. It proves the concept works brilliantly. The idea Germany tested and lost to bombs, America refines and deploys. The echo of the Me-109Z reverberates through Korean skies, flown by pilots who never knew its German origin. As Germany collapses in 1945, experimental projects are abandoned. Factories are obliterated by bombing. Blueprints are burned as armies advance. Engineers flee west toward Americans or are captured east by Soviets. The Soviets seize production facilities in occupied territories. They study captured tooling extensively. They reverse engineer components. They even build post-war versions, the S-1999, using salvaged parts and Czech manufacturing. The S-1999 flies combat in the Israeli Air Force during 1948, a German fighter built by Czechs flown by Israelis against Arabs. History's circular irony. Archives scatter across zones. Some documents reach America through Operation Paperclip. Others disappear into Soviet vaults, never declassified. The most radical experiments, glider fighters, jet hybrids, rocket-assisted variants, are lost or buried under classification. Historians piece together fragments over decades. A diagram here, a memo there, fading testimony from elderly engineers. But the complete scope remains incomplete. Some ideas were too ambitious, some too dangerous. Some ran out of time as the Reich burned. April 1945. Americans capture Augsburg and occupy Messerschmitt factories. They find hundreds of abandoned Bf-109 airframes, half-assembled fuselages on jigs, missing engines, wings stacked in bombed warehouses, production lines utterly silent. Workers fled or conscripted. American intelligence officers walk through echoing factories examining assembly jigs on concrete floors. They photograph everything. They study the simplicity with growing respect. They finally realize what bureaucrats missed in 1936. Messerschmitt's focus on production efficiency wasn't arrogance, it was strategic foresight. Germany built $34,000 Bf-109s because the design allowed nothing less. Production speed was embedded in every component from the beginning. The factory proves Messerschmitt was right. The fighter that opened the war and nearly died before birth outlives the regime by decades. Post-war air forces study it obsessively. Engineers dissect surviving examples. Former Allied pilots write memoirs describing the DB-605s, scream the sudden vertical dives, the narrow margin between escape and death. The Bf-109 becomes a symbol not of ideology but of pure engineering discipline under pressure, of what happens when a designer refuses compromise despite overwhelming opposition. Germany's most radical experiments vanished in rubble and flames, but the philosophy survived because momentum once started doesn't stop at borders or even at war's end. Nearly 34,000 Bf-109s are produced between 1936 and 1945, more than any fighter in history, born from bitter personal rivalry, forged through battlefield experimentation, shaped by uncompromising design philosophy. It becomes the Luftwaffe's backbone for a decade of total war, a blueprint for future fighters worldwide. Messerschmitt didn't create perfection. Perfection was never the goal. He created momentum, unstoppable momentum that reshaped air combat doctrine across 3 continents, rewrote tactical manuals in every major air force, permanently redrew the sky for generations who followed. The narrow landing gear that nearly killed the program becomes its defining signature. Pilots curse it. Mechanics hate it. But it forces absolute precision in every landing, unwavering discipline in every approach. The unforgiving gear teaches what classrooms cannot, that modern war forgives nothing. No error, no hesitation, no inattention. The Bf-109 isn't forgiving. It punishes mistakes with broken gear or ground loops. It rewards skill with survival. In that sense, it's completely honest. Ruthlessly honest. Like the war it was designed to fight. Willy Messerschmitt survives the war. Arrested by Americans in May 1945. Questioned extensively, eventually cleared. He returns to engineering in the 1950s. Designs civil aircraft, writes technical papers. He never apologizes for the Bf-109's demanding characteristics. When journalists ask why he refused to soften the design despite complaints, he responds bluntly, "I built what was necessary for survival, not what was comfortable for peacetime." The philosophy persists until his death. Engineers still debate it. Should machines adapt to humans or humans to machines? The Bf-109 answered decisively. The fighter's legacy extends far beyond Germany. Soviet designers study captured examples. American engineers examine seized prototypes at Wright Field. British pilots fly restored examples and publish classified reports. The Spitfire evolves responding to Bf-109 capabilities. The P-51 incorporates lessons learned fighting it. The FW-190 is designed to address its limitations. Every significant fighter that follows carries its shadow. Speed as survival, structural simplicity for mass production, vertical energy over horizontal turning. These principles become universal truths into the jet age. In air shows today, restored BF-109s still fly. The DB-605 still screams. The airframe still climbs at impossible angles, demands complete attention. Some spectators know the complete history, the Vendetta's near-cancellation Spanish trials. Others see only a relic, but pilots who fly them understand immediately. The BF-109 doesn't forgive sloppy technique. It never did. Perhaps that's the point. War doesn't forgive either. War doesn't care about comfort. War demands everything. The BF-109 reflected that reality with absolute honesty. They didn't conquer the sky. They learned to respect it. Respect its violence, its indifference, its absolute demands. The BF-109 was never the most beautiful fighter, never the most comfortable, never the easiest to master, but it was the most produced in history, the most adapted across theaters, the most enduring symbol of engineering discipline meeting strategic necessity. Because Messerschmitt understood what others refused, that war is won not by the best machine, but by the machine that can be built fastest and flown hardest when everything is burning. The paradox stands. A fighter nearly killed by vendettas became the most produced in history. A design hated by test pilots became their most reliable weapon. An engineer dismissed as reckless created an Air Force's backbone. The BF-109 didn't change the war because it was perfect. It changed the war because it was inevitable. And inevitability, once set in motion, cannot be stopped by elegance, comfort, or spite. The sky remembers. The sky always remembers.